Hi, a warm welcome to you. As part of this video, we'll be learning about law of sines as part of applications of trigonometry. So the idea is that we know that trigonometry gives us the ratios of the sides of the triangle, with the help of which we can actually find out the inaccessible distances, or as we have seen, are the heights of the inaccessible objects, as we have seen with respect to heights and distances. So now applying trigonometry to triangles and see, like, can we leverage the trigonometry to find simpler ways to find out, let us say, something like area of a triangle. So if you have a triangle, let us say right angle triangle with base B and height h, we know that the area of triangle equal to half base into height. It's pretty straightforward and simple, but suppose you have a triangle like ABC where the height h is not given and it's not a right angle triangle, then you have to do a lot of math. You have to divide AB into two parts, then you have to say that this altitude will divide this in the ratio of AC is to CB. So you have to do a lot of work to come with h, then only you can say half base into height. But can we leverage trigonometry and find a simpler ways how we can calculate the area of a triangle, which has led to the derivation of law of sines? Okay, right. So let's have a look at law of sines. You can see that there are there is a triangle represented in two ways. So this is a triangle ABC. As I said earlier, the side length opposite angle A is small a. Similarly, the side length opposite angle B is small b, and the side length opposite capital C is small c. You can see the two triangles. I have taken the same triangle, only the thing is here I have taken base of the triangle as AB, and altitude equal to small h. In the second case, you can see that the base is equal to BC and the altitude is nothing but equal to h1. So what we want to prove here is there any simpler way, instead of I calculate h by using all the mathematical manipulation or concepts what I have to do, can I leverage trigonometry if I know the angles of this triangle? Then can I apply and find out something? So let's try to do this. Okay, now whole discussion is revolving around altitude, height, h. So let's go ahead and see how you can represent side how you can represent the altitude h in terms of trigonometrical ratios. Okay, now you can look at the triangle ADC. You can clearly see that sine of A is nothing but equal to height, that is nothing but opposite side, divided by the hypotenuse. So you can immediately say that sine of A, from here I am looking, is equal to h divided by, what is the hypotenuse in this case? B. Now this is, you are looking from A. Now let's look from the other side of the world. Okay, let us look from B. If I look from angle B, what is this? I can say sine of B is equal to, again opposite side is h divided by hypotenuse is in this case A. You can see that h is a common variable in both. So I can say h is equal to B sin A here. I can go ahead and say h is equal to B into sine of A. Here h is equal to A into sine of B. Let's just keep it as equation number 1. Now let's come to the second case. What I have taken here, I have taken base as BC. In, not to confuse you, let me just put this in and say that this is the second case and this is the first case. This is the case number 1 and this is the scenario or case number 2. Let's come to base BC and the altitude H1. Okay, right. Now what we can see from there? We can see, let us say we want to find out the H1. So if I look from this angle is 90 degrees, that's what we are saying. So if I look from angle B, can I say that sine of B is equal to H1 divided by, what is the hypotenuse here? C, correct. Similarly, if I look from the other side, can I say that sine of C from this side, opposite is H1 divided by hypotenuse is B. So this becomes, again, this is from there. Similarly, from here you will get H1 is equal to, this is small c into capital B, also H1 equal to B into sine of capital C. But you can see here we got already, you can see here if you manipulate this, this becomes nothing but sine of A by A equal to sine of B by B. Similarly here I will get sine of B by B equal to sine of C by C. So what this is giving? What this is giving? Let's write them down. So this is giving me that I can keep trigonometric ratios on one side to the ratio of the length A to A, okay, on one side. This becomes sine of A by A, sine of A by A equal to sine of B by B. From here you can see that from the second one you can see that sine of B by B equal to sine of C by C. Sine of B by B equal to sine of C by C. For this whole derivation there is only two points. First point, remember always that the length of the side opposite to the angle is denoted by the lower version of the angle. So if you are looking from angle A, the length opposite to you, that's BC, is given by lower version of, that means small letters of A. Similarly, B angle, it's a small b. C angle, it is small c. That's only the thing. And another thing what we did here, we actually want to find out the area of the triangle in a simpler version. So we started with altitude because area is of base into height, and base is very straightforward, but height is where I have problem. Because if I have been given a triangle where it is not a right angle triangle, I have to do lot of work to find out what is this height. So I want to leverage trigonometry. If I know the angles of the triangle, then how I can use that and I can calculate the area of the triangle. Now you can see sine of B by B is common here in both of them. So you can go forward and say law of sines, which says that sine of A by A is equal to sine of B by B equal to sine of C by C. This is nothing but called as law of sines. Okay, right. Now how this will help you to find out the area is, area of the triangle is very simple. You know that sine of A by, so now what is our height? Our height is nothing but B into sine A, correct? But you can write sine A in terms of other angles also. So you know any angle. Now if I simplify this, don't take much of your time. This becomes like, let us take the first case here, of into, okay, what is this? C, of into small c, that is nothing but base, into height. What is h? H is nothing but b into sine A, or also I can write it as of into C into small c, this is into, I can also write it as A sin B. So the to simplify, the area of the triangle can be find out by of AB sin C or of BC sin A of CA sin B. That means if I know two sides of a triangle and the angle between them, if I know CB, if I know two sides of triangle AB, AC are given by C and B, and the angle between them are these two sides and the angle between them are these two sides and the angle between them, I can find out the area of the triangle. I don't need to apply Pythagoras, find out what is the ratio in which the base is divided, then apply Pythagoras theorem and find out the altitude. You don't need to do much hard work. In the next video, we will take a simple example and see how this concept works. We'll take a simple right angle triangle where you know area equal to half base into height, but we'll cross check how this particular formula will make it easy for you, and you can generalize it for any triangle where you know either the angles of the triangle and one of the distance. If you very simple, very easy, whenever you know two sides and a common angle between them. But not only that, you can see here, if you know out of these four any three variables, you can find out the fourth one. So if I know angle A, angle B, and I know distance A, I can find it out because I know C equal to 180 minus of A plus B. So you can apply all these formulas and make it very simple. In the next video, we will see, we'll take a simple example and apply this concept and see how you can calculate the area of the triangle, and also show that all this lead to the same thing of CB sin A equal to CB sin A is equal to, or actually I have to say of BC sin A equal to of CA sin B is equal to of AB sin C. Catch you in the next video. Thanks for watching. Bye for now.